In this video, we will go over the calculation of how to calculate the frequency and how to calculate the wavelength of electromagnetic radiation. So you have to remember that these radiations travel at the speed of light, which is 3 times 10 to the 8 meters per second. We also have to recognize that the wavelength lambda times the frequency v, how fast the wave travels, is going to equal to some speed. And again, as stated before, since this is electromagnetic radiation, it's going to travel at the speed of light, which is 3 times 10 to the 8 meters per second. So this has to do with the electromagnetic spectrum, radiation, and microwave radiation is definitely a part of the electromagnetic spectrum. So we're going to utilize this equation here. Part A is asking us for the frequency of light. Light is the visible part of the electromagnetic spectrum that has the wavelength 456 nanometers. So the first thing we want to do is convert this to the standard unit of meters. So we have 456 nanometers, and the proper conversion is that 1 nanometer is, nano is a very small number. Nano means minus 9. So 1 nanometer is 10 to the minus 9 meters. So that's going to be 4.56 times 10 to the minus 7 meters. Know that lambda times the frequency is equal to the speed of light, and speed of light is 3 times 10 to the 8 meters per second. We need to solve for the frequency in this problem, part A. So frequency is equal to speed of light, c, divided by lambda, wavelength. So that's going to be 3 times 10 to the 8 meters per second. So I'll put the meters per second here, divided by lambda, which we already determined to be 4.56 times 10 to the minus 7 meters. Meters cancel. We're left with inverse seconds, or 1 over seconds, which is we know is hertz. And doing that on my calculator, 3 times 10 to the 8th divided by 4.56 times 10 to the minus 7 gives us a value of 6.58 times 10 to the 14th over seconds, which is the same thing as 6.58 times 10 to the 14th hertz. Remember, hertz is the same thing as 1 over seconds. Light is going to be speed of light c divided by frequency. The frequency given to us in this problem is 2.45 times 10 to the 9th hertz. So here lambda is going to be c over v. C we know is the speed of light at 3 times 10 to the 8 meters per second. Meters per second. And this frequency v is going to be 2.45 times 10 to the 9th hertz. Okay, that's what they gave us here. Hertz is 1 over second, so I'll just put in over seconds here because it's 1 over seconds. And seconds cancel. So 3 times 10 to the 8th divided by 2.45 times 10 to the 9th. Doing that on my calculator and getting the final units of meters, I'm getting 0.122 meters. So, 10 to the 9th hertz, a very large frequency magnitude-wise, very large number, 10 to the 9th, would equate to a very small wavelength. Okay, large frequency, small wavelength and frequency are of an inverse proportionality.